Let's find the limit as x approaches pi over 2 of cosine over the fourth root of e to the tangent x. Now, I'm going to rewrite this. So e to the tangent, the fourth root of e to the tangent is the same thing as e to the tangent raised to the 1/4 power, which is cosine over e to the tangent over 4. And when we bring it up, you get the same thing, but now the exponent is a negative. In order to solve this as x approaches pi over 2, we must consider the left hand and the right hand limit because tangent behaves differently from the left of pi over 2 and from the right of pi over 2. So this is what tangent looks like. So 2 periods of tangent. As you can see, from the left, you're going to positive infinity, and from the right, you're going down to negative infinity. So we must split this up. The easy one will be looking at the left of pi over 2, but then from the right of pi over 2 will require a bit of work. Note that cosine of pi over 2 is 0 for both of these. And we just got to figure out e to negative tangent over 4. Well, as x approaches pi over 2 from the left, that's over here, that's going to positive infinity. So it's e to negative infinity over 4, really, because you're multiplying the positive infinity with the negative. And so e to the negative infinity, that goes to 0. So both of these limits go to 0, and when I multiply them, 0 times 0 is 0. Versus now, e to the negative tangent over 4, tangent goes to negative infinity as it approaches pi over 2 from the right. So the two negatives here will make it positive. So e to the positive infinity will be infinity. So this is an indeterminate form, which means I want to use L'Hopital's rule. And the way we're going to do that is by converting the 0. We're going to rewrite 0 as in 1 over 0. So you're basically taking 1 over the reciprocal is equal to the original function, because now we will get infinity over infinity. So we can use L'Hopital's rule. So L'Hopital's rule says take the derivative of the top, derivative of the bottom. So for the top, we're still going to have e to negative tangent over 4, and then we have to take the derivative of negative tangent over 4, which is, well, pull out the 1/4, and you have a negative, and then the derivative of tangent is secant squared. And then now we need to take the derivative of 1 over cosine, but 1 over cosine, think of that as cosine to the negative 1 power. And you want to use a chain rule, so bring down the exponent, keep the inside the same, subtract 1, and then take the derivative of the inside. So the two negatives will make a positive, so you can think of this as sine over cosine squared, which is tangent times secant. Because it's sine over cosine times 1 over cosine. Okay, so that's what we're going to use here. So we'll write tangent times secant. Okay, we can factor out the negative 1/4. We have limit as x approaches pi over 2 from the right. And then the secant will cancel on the bottom, and then we'll remove the exponent. And then we have secant over tangent. So secant over tangent is the same thing as 1 over cosine over sine over cosine. And so if you multiply the top and the bottom by cosine, these will cancel, and you're left with 1 over sine, which is cosecant. So this is e to negative tangent over 4 over, so yeah, we'll just say the cosecant would have been on top, but let's just put it on the bottom as just sine. Okay, so it doesn't matter if you put it on the bottom or the top. I think it's just easier to deal with sine, because as x approaches pi over 2, sine goes to 1. So you can use the quotient rule where you split this up into two separate limits, and yeah. Anyway, so when you do that, really this goes to 1, so it's not even worth worrying about it. So we just need to worry about e to the negative tangent over 4. And then here we're approaching pi over 2 from the right, so let's see what happens. As we're approaching pi over 2 from the right, this is going down to negative infinity. So we have negative 1/4, and then tangent over 4 goes to negative infinity, but then you have a negative multiplying that, so that should go to positive infinity. You have e to the positive infinity goes to infinity, so you have a negative number times infinity should give you a negative number, or negative infinity, I mean. So in other words, as x approaches pi over 2 from the right, it's going to negative infinity. From the left, we said it's going to 0. So because the two limits are not the same, we say that the original limit does not exist.